So, what if I told you the universe is fundamentally weird? Like, way weirder than even Albert Einstein could get on board with. Well, today, we're diving into a discovery so mind-bending, it completely rewrote the rules of reality itself. Let's get into it.
I mean, that sounds like something straight out of science fiction, doesn't it? But, this isn't just some fun hypothetical. It's a real, baffling thing that happens in quantum physics, a mystery that really forced us to rethink our most basic ideas about how the universe works.
It's called quantum entanglement. And here's the gist. Imagine you have two coins that are magically linked. You flip one in New York, and it lands on heads. Instantly, you know the other one, all the way over in Tokyo, just landed on tails. Quantum particles can do this, appearing to communicate faster than the speed of light. Einstein, for one, absolutely hated this. He famously called it spooky action at a distance.
And that spookiness is right at the heart of a huge scientific debate. I mean, this wasn't just some small disagreement. This was a battle for the very soul of physics, pitting the great Albert Einstein against another giant, Niels Bohr.
This quote right here, it perfectly sums up Einstein's entire worldview. He just believed deep down that the universe had to be orderly and predictable, a place with clear rules of cause and effect. The pure randomness of quantum mechanics just felt, incomplete to him. He was sure there was some deeper, hidden reality we just hadn't found yet.
So to get rid of all that spookiness, Einstein came up with an idea called local hidden variables. It's actually a pretty clever way around the problem. He said, look, the particles aren't talking to each other at all. Instead, think of it like they each get a secret instruction manual the second they're created. This manual tells them exactly how to behave later on. And the key word is local, meaning no weird faster-than-light signals. The results just seem random to us because we can't read the instructions.
Okay, so you've got these two totally opposite views of reality. On one side, you have Niels Bohr and his camp saying the universe is truly random and that entanglement is a real, super weird connection. On the other side, you have Einstein saying, no, it's all just an illusion caused by these hidden instructions. For decades, this was just something physicists argued about. I mean, how could you possibly prove which one was right?
Well, this is where our hero, a physicist named John Stuart Bell, enters the picture. Back in the 1960s, he figured out an absolutely brilliant way to take this argument out of the philosophy department and into the lab. He designed a test to, basically, force nature to show its cards.
Bell's genius was to reframe this incredibly complex physics problem as a simple game. A game with one purpose: to find out if these particles were just following a pre-written script or if something much, much stranger was really going on.
So here's how the game works. First, you create thousands of pairs of these entangled particles. Then you shoot them off in opposite directions, each one heading toward a detector. Now, here's the crucial part. At the very last second, each detector randomly chooses an angle to measure its particle at. After that, you just write down the results from both sides and see how they match up. Simple enough, right?
Okay, now the scoring rules are a bit quirky, but they're specifically designed to mess with any secret instruction manual. You get a point if the detectors happen to pick the same angle and the particles give you different results. But you also get a point if the detectors pick different angles and the particles give you the same result. These rules are made to put any pre-planned strategy in a real bind, and Bell proved mathematically that if the particles were using a secret plan, there's a hard limit to how often they could possibly win this game.
And this is where it gets really, really good. That limit Bell calculated, it's not a guess, it's a hard mathematical fact. If reality is local and predictable, the way Einstein believed, then this game has a kind of speed limit that is just physically impossible to break.
And that limit is 75%. If particles are just following some kind of pre-written plan, there is absolutely no way they can win this game more than 75% of the time. That is the absolute maximum score for a classical Einstein-style universe. So, the billion-dollar question is, what score does our actual universe get?
So, physicists actually did it. They set up the experiments, they entangled particles, they sent them flying, and they played this cosmic game over and over and over again. They tallied up all the wins, calculated the final percentage, and you can imagine them holding their breath. What was reality's score? The universe scored about 85%. It didn't just squeak by the classical limit. It absolutely shattered it. This result proved, beyond a shadow of a doubt, that the particles were coordinating in a way that is just impossible for any hidden, pre-written script. The spooky action was real. And by the way, this weirdness isn't just a fun fact, it's the core principle that makes things like quantum computing possible.
So, the official term for this result is the violation of the Bell inequality. But what it really means is that Einstein's idea of a secret instruction manual, well, it just doesn't exist. The universe does not play by the classical rules we all thought it did.
So, after decades of debate and some incredibly clever experiments, we finally had a verdict. And honestly, it caused a seismic shift in how we understand, well, everything.
And this journey wasn't a quick one. It started with Einstein's formal challenge way back in 1935, then Bell's theoretical breakthrough in '64, and then decades of more and more precise experiments. This whole incredible saga finally culminated in the 2022 Nobel Prize in Physics, which was awarded to the scientists who basically slammed the door shut on any lingering doubts.
The takeaway here is crystal clear. The spooky action at a distance is real. There are no hidden variables, no secret strings being pulled from behind the curtain. The universe at its very core runs on probability and true, undeniable randomness. And on this one huge question about the nature of reality, Albert Einstein was wrong.
And so, we're kind of forced to turn Einstein's most famous declaration right on its head. The evidence is in, and it tells us that not only does God play dice, but that the game of chance is woven into the very fabric of our existence.
Which leaves us with one final, pretty mind-bending thought. If the foundation of our entire universe isn't some predictable machine, but is actually a cosmic game of chance, what does that imply for big ideas like fate, or free will, or even time itself? The dice have been rolled. What happens next is really anyone's guess.